folks. We have now multiplied matrices. Now we're going to evaluate a determinant of a matrix and apply Cramer's rule. And Cramer's rule is something that you have to do in order to solve a system of equations. So we'll get there. You'll get to see exactly what that means. Let's get into it. First thing we got to be able to do is find a determinant. Okay, size restrictions. The matrix must be square if you're going to find the determinant. Okay, it must be square. You can't have a 3 by 2. It needs to be a 2 by 2, 3 by 3, 4 by 4, something like that in order to find the determinant. For this class, we're only going to deal with 2 by 2s and 3 by 3s. Now, a little notation difference. This is how we denote a matrix, but if you're finding the determinant, you use two straight lines. That tells somebody you want to find the determinant. Okay? Here's how it works. To find the determinant, you take the main diagonal and multiply. So that's 5. And you subtract the opposite diagonal, which is 12. So in this case, our determinant is negative 7. Take the main diagonal, multiply, and subtract the other diagonal. Okay? Now, 3 by 3, little different, little more work. Okay? We'll get into it here. First thing you're going to want to do on the main diagonal is you're going to want to rewrite the first two rows outside here. So 2, 4, 3, negative 1, 1, negative 4. And you'll see why we have to do this when we get going here. So first thing we got to do is we got to do the main diagonal. Okay? So right there. So 2 times 1 times negative 2. Now because it's a 3 by 3, okay, the rules change. We've got to continue multiplying on the diagonal. This is why we add the rows. So we're going to add this to negative 1 times 0 times 3. Then we're going to add that to, finally, the last one. Okay, negative 3 times 4 times negative 4. Okay? Now, once we have that, okay, then we need to subtract the opposite diagonal. So that'll be 3, oops, 3, I did it again. Hold on, let me just rewrite the whole thing. 3 times, this is all in parentheses here, we got to subtract the whole thing. So 3 times 1 times negative 3. Okay, now we go here. Plus 4 times 0 times 2 plus the last one, which is negative 2, 4, negative 1. Okay? So let's just simplify each piece so we can see what we have. So I have negative 4 plus 0. Let's see, and then we've got 12 times 4, which is 48. Plus 48 minus negative 9 plus 0 plus 8. If I multiply everything down here in green. Okay? So now I'm going to have to distribute my negative through and find things out. So I've got actually, it's a positive 44 plus 9 minus 8. Okay, so that ends up with 53 minus 8, which is 45. My determinant in this case is 45. So it's obviously a little easier with a 2 by 2. You only have the main diagonal and the other diagonal to worry about. With a 3 by 3, things add up. Okay, you're going to have to add a couple rows and make sure you multiply all the diagonals together. Okay? Finding the area of a triangle. This is kind of a neat little trick that you can use if you have the coordinates of a triangle. So let's just graph these coordinates real quick. Okay, and then I got negative 1, 4, and 4. 1, 2, 3, 4, Okay? I'd like to find the area of that triangle. Now that's not real easy because I don't have a real easy height here to go base times height. Okay? So finding determinant will help things out. Now here's the general equation. This is in your book. Area is 1/2 times the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. So essentially you find the determinant of this matrix, and then you multiply by 1/2, and that'll give you your area. So let's plug in what we know. x1, y1 is 0, 0, and then a row of 1s to make it square is why we have this row of 1s, because I need the thing to be square to take a determinant. Then I've got -1, 4, 1, 4, -4, 1. I need to find the determinant of that and then multiply it by 1/2. Okay, so here we go. Well, let's get after it here. First thing I need to do is I need to rewrite some numbers out here. So 0, -1, 4, 0, 4, -4. Okay? Well, main diagonal here, that's 0 times 4 times 1. I'm just going to write it all down here. Just multiply to begin with. So that's 4. Plus, oh, that's 0, rather. So I've got 0 plus, the next diagonal is 0. Plus 1 times -4 is a positive 4. Minus. Now I need to go the other way. Let's go with a different color here. Okay, that is 8. And then minus 4. And then minus 1. Okay, and we're going to take this times 1/2 all together when we're done. Okay, so let's go ahead and keep solving. So I got 1/2 times 4 minus 8 plus 4 minus 1. Okay, good. I feel like something is going wrong here. 0, 0, 4. That's right. 8. Oh, I did do something wrong. Sorry about this. This is a 0. This is a 0. So that changes some things down here. I forgot these zeros there. Sorry about that. Okay, let's fix things now. Good. 1/2 times 4, excuse me, minus 8. Okay, good. So that gives me 1/2 times -4. Excuse me, which gives me -2. Holy smokes, I got a mess going here. This is 16. Wow, I've really messed this one up, guys. Sorry about this. 16, and that makes this a 16, which makes this a 12, which makes this a -6. Now, we can't have a negative area, so the answer is 6. Now, I'll show you why I knew that that wasn't a good answer when I got 2, because if I look at the area, I can just find 2 squares in there like that. I knew it had to be bigger than that. 6 is definitely a much more reasonable answer, okay, because you start piecing things together. 6 is going to be closer, okay? Messed up my sign. I neglected the zeros. I couldn't multiply 4 times 4. Whew, wasn't a good one, okay? But we ended up with the right answer there. That happens in math. You make mistakes, okay? But you got to be able to look and see if your answer is reasonable so you can go back and fix it if you need to. It's exactly what happened here. Okay, made a couple of mistakes. Obviously wasn't getting the right answer. Went back, checked my work, and got the right answer. Okay? Cramer's rule. Here we go. Cramer's rule. This is something that we use to solve a system of equations. Okay? here's the basic idea. We need to make 4 square matrices. Okay? First matrix we make is the coefficient matrix. We're going to use everything that has a coefficient with it. So 9, 4, 3, negative 5. And the first thing we have to do is find the determinant of this. Well, it's easy because it's a 2 by 2. Okay? So let's see here. We're going to have negative 45 minus 12. So that gives us negative 57. Okay? Negative 57 is our answer. Now, to figure out a value for x, to figure out where these things intersect with x, you need this. This is, they call this the determinant of A because they call the coefficient matrix matrix A. Okay, so what you need to do is you need to take this original matrix, okay, and you're going, if you want to find x, you're going to take out the x row, you're going to take that out, and you're going to plug in the row of answers that you have. So it's going to look like this. You're going to find the determinant of negative 6, negative 21, 4, negative 5. And then we're going to divide by the determinant of A, which is negative 57. And that will give you your answer for x. Okay? Let's try it here. So I have 30 minus, what is that? A negative 84. And we're going to divide by negative 57. Okay, well, this gives me a 114 over negative 57, so that is a negative 2, and that's what x equals. X equals negative 2. Okay, now if I'm going to find y, I do the same thing. I start off with this original matrix. I take out the y column, because that's what I'm trying to find, and I plug in the answer column. So I take the determinant of 9, 3, negative 6, negative 21, and I divide it by negative 57 because that was the determinant of my coefficient matrix. Okay, so this gives me 9 times 21, it's 189, negative 189 minus negative 18. Divided by negative 57, and again, this is what y is going to equal. Okay, so 189 plus 18 is going to be 171. So I've got a negative 171 divided by negative 57. Divide that out, y is going to equal positive 3. There's my answer, solving a system of equation with Cramer's rule. You do the same thing with a 3 by 3. I'm not going to do an example of that because it takes a while, but hopefully this makes sense. And we'll see you in class.